All right, students, welcome to today's explainer. Grab your notebooks and get ready to focus. Today, we're going to completely demystify command line arguments in C. We'll be tackling the C06 module together, going step by step through exercises 00 to 03. Look, I know pointers and arrays can seem super intimidating at first, but honestly, you've got this. As your instructor, I'm here to guide you through every single logic hurdle and give you the tips you need to pass this module with flying colors. So here's our game plan for today. We'll start with the magic of CLI arguments. Then dive straight into exercises 00 through 03, building our logic all the way from printing a simple program name to algorithmic ASCII sorting. Let's get to it. Okay, part 1, the magic of command line arguments. Before we even think about writing a single line of code, we really need to understand the environment. How does your C program actually receive data directly from the shell when a user types a command? Up until now, you've probably just written int main void. But to accept arguments from the command line, our main function uses two very special parameters. First up is argc, which stands for argument count. This is just a simple integer that tells us the total number of items passed. Keep in mind this includes the program's name itself, so argc is literally always going to be at least 1. Second, we have argv, the argument vector. This is an array of strings, or in C terms, an array of character pointers, that contains the actual text of those arguments. To put it in perspective, when you type ls-l in your terminal, this is exactly how the operating system passes that -l flag into the ls program. Let's map this out visually so you can see exactly where everything lives in memory. At index 0, or argv of 0, we have the command used to run the program itself, something like /a.out. Then, from index 1 all the way up to argc-1, we find the custom parameters that the user actually typed in. And here is a massive pro tip for you when you're writing safe code. The C standard actually guarantees that the very last element at index argc is a null pointer. It acts as a built-in end-of-array marker. This is huge because if you ever need to iterate through your arguments without strictly using the argc integer, you can literally just loop until your pointer hits null. Moving right along to part 2, exercise 00 program name. Let's look at our first practical challenge and see how this builds our foundation. Your job here is super simple. Just get the program to introduce itself. Now, as a student in the Piscine, you know you always have to pay strict attention to the rules. Your turn-in directory is x00. The absolutely only allowed function is write, so no, you cannot use printf or strlen. The goal is to display the program's name followed by a new line. And importantly, since this isn't just a helper function you're writing, you have to include a full main function to actually compile the executable. So how do we actually solve this? Let's break it down into steps. Step 1, grab the program name, which you know is safely stored at argv0. Step 2, because we're stuck using the write function, which needs an exact byte count, we have to iterate through that string at argv0, character by character, until we hit the null terminator. That's how we find its length. Step 3, once you have that length, use write to output the whole string. And finally, step 4, do a quick 1-byte write call to print the new line character. And hey, don't forget, a new line is just a single character in C. Pretty easy, right? All right, part 3, exercise 01, printing parameters. You nailed the first one, so let's step it up. In exercise 01, things get just a slightly more complex. We now need to handle whatever the user types after the program name. You've got to display all the arguments in their exact original order with a new line after each one. But here's the catch. You must absolutely skip the program name at index 0. If your program prints /a.out along with the arguments, the automated tests are going to fail you instantly. Here's my tip for your logic breakdown. To skip argv0, just initialize your loop counter variable to 1, int I equals 1. Then use a while loop that runs as long as I is less than argc. Inside that loop, you're going to apply the exact same logic we just wrote for exercise 00. Find the length of argvi, use write to print it, write a new line, and then increment I. By simply starting at index 1 instead of 0, you perfectly bypass the program name. No messy if statements inside your loop required. Okay, part 4, exercise 02, reversing parameters. Now we're really getting into some algorithmic thinking. In exercise 02, we take the exact same concept from exercise 01, but we flip it entirely in reverse. Let's compare the logic closely here. In forward iteration, we started at index 1 and moved up. So to print in reverse, where do we start? Listen carefully, because a very common mistake is starting at argc. Remember, argc is the total count, which means the array index argc is actually that null pointer we talked about earlier. You don't want to print that. Therefore, your backward iteration absolutely must start at argc -1. And instead of moving up, you loop while I is greater than or equal to 1, ensuring you stop before hitting index 0. So your implementation is going to look just like this. Initialize I to argc -1. Make sure your condition is I greater than or equal to 1 so you don't accidentally miss the very first user argument. Inside the loop, your printing logic is identical to before. The only change at the end of the loop is that you decrement your counter, I --, on each pass. It's a fantastic exercise to really get comfortable with array boundaries. And finally, part 5, exercise 03, sorting by ASCII. All right, take a deep breath for this one. This is the true test of the C6 module where we introduce algorithmic sorting. The rules here dictate we must display the arguments sorted by their ASCII value. We still skip argv sub 0, and we still can only use write. But the big challenge here isn't the printing part, it's figuring out how to rearrange the pointers within the argv array before you print them out. This exercise brilliantly illustrates the sheer power of pointers in C. You see, you don't need to move heavy text data around in memory. You literally only need to swap the lightweight pointers inside the argv array. Step 1. Set up a basic bubble sort, which just means nested loops. Step 2. Write your own helper function, like ftcmp, to compare two strings character by character based on their ASCII values. Step 3. If the string at argvj is greater than argvj plus 1, you swap their string pointers. Just create a temporary char type variable and switch them around. Once your nested loops finish sorting the array pointers, step 4 is literally just reusing your exact code from exercise 01 to print them sequentially from index 1 to the end. We've done the heavy lifting together and mapped out the logic for every single step. You know exactly how argc and argv function, you know how to safely iterate forwards and backwards, and you know how to sort pointers using string comparison. As a student, understanding this theory is half the battle. Now it's your turn. Open up your text editor, trust the process we just laid out, and bring these algorithms to life. You've just learned how to make your C programs actually talk to the outside world. So ask yourself, now that your program can accept real-time commands and sort them in memory, what kind of custom terminal tools are you going to build next? The command line is totally yours now. Good luck, students. You're going to do great.